Okay, welcome back. Just a moment, please. Okay, so welcome back, everybody. Sorry for the slight delay in takeoff. So we'll be continuing from this point, dictionary methods. Oh, sorry, dictionaries first. Yeah, dictionaries. So a dictionary is a collection of objects that maps a key item to a value item. So it's a collection of objects that maps a key item to a value item. So think of it as a name value pair. So in a dictionary, you have a name and you have the value. Just like your typical dictionary, if you were to look up for a word, you're going to get the meaning of the word with it. So if I want the meaning of, say, excellent, I'm going to look for excellent, and it's going to return the meaning of excellent. So here you look up the key and it's going to return the value item for you. So let's create our first list. So in order to create a list is created as such. You open a curly braces or a pair of curly braces, you open and close, and in between it, you're going to specify the key item and the value of that key. So here, the first key is name, and the value of the name is Ola. The second key item is age, and the value is 34. And the third key item is occupation, and the value of it is nurse. So let's print it out. So there it is. Age, 34, name, Ola, occupation, nurse. You should notice that it has rearranged the order of the order of the dictionary key value pairs. So, but if you also look carefully, you realize that it arranged it in the order of appearance, or in the same way it is going to sort a list of the keys. Here the keys are age, name, and occupation. So A comes before N comes before O. So that's how it's, or that's how dictionary rearranges the item, the key value pairs in it. But it does not lose the value for each of the key items. So now let's see, how do we get values, the value items from a list? Getting values from, let me see, getting value items from a list. So now, the list I created is my dict. Say I want to get the name, the item, the value corresponding to name in that dictionary. So I simply, okay, if you remember how list works, if these were a list, I'm going to pass in the index I want to get here, right? So think of, in place of index, we are having keys here. So instead of identifying a value by its index, we identify a value by its key. So the key name has a value, Ola. Here, the key age has the value 34, and here the key occupation has the value nurse. So dictionary is actually a very fantastic way of storing values in Python, or storing data, collection of data. What makes it very fantastic is you can store data with labels or with keys. What we just did now is a very simple example. It could actually be extended to a dictionary of dictionaries. So here, I could maybe have names, assume I want to have names of students in the class. And what this is going to be, I could just pass list of the names there. Or assume I want to have, so I want to have name. So for each name, I want to have key value pairs for that name. So assuming I'm trying to describe each person. So I'm storing one person's information as key value pair, and that person's information as key value pair. So now let's take one person now. So the person I'm storing as key value pair, assuming the key is the name of the person, say Ola in this case. So Ola as the key. The value of Ola is now going to be another dictionary that is going to carry some attributes of Ola. So under it, I can have maybe age. I'll give age. I can have date. Okay. I can have say interest. I'll give the interest. I can have school attended. I'll put the school attended. This is quite abstract. Let me just write it out. I think it's going to make a better read that way. So I'm just going to copy what I have here. Copy it over here. Now, so here I have Ola as a key, then this dictionary as a value of Ola. So that is just one key value pair. And you'll see the dictionary as well has some key value pairs in it. So let me have another key, Kofo. So, and I'll have another dictionary for Kofo that's going to carry Kofo's age. Let me copy this over. So I can modify the values. Kofo is 28. Kofo's occupation is, Kofo is an engineer. So let's see it. See, this is what makes dictionary a very, very powerful tool. In fact, there is even a more verbose version of it, which is called JSON. JSON is called JavaScript Object Notation. So it's a way of storing data as key value pairs or as dictionary in dictionaries. So what I have here, I think this is what JSON is more often referred to as. So I could probably just call this one a dictionary and maybe call everything I have here JSON, but it would also be valid to call it a dictionary as we're doing here. Okay, so moving ahead, getting value items from a list. So I want to get name. Okay, I think we've discussed this. Indeed, with this new list I have now, I'll probably change this to say I want to get Ola, and it's going to return the. Okay, let me see. Something is first. Oh, sorry, it should be first dict, not my dict. Okay, so there you go. It returns age 34, occupation nurse. So assuming I want to anybody, if I have very many names here, and I want to get the person's anybody's name and age and occupation rather, I'll simply put the person's name here. So here I could say Kofo, and it returns Kofo's attributes, and I could this dictionary here could also be a dictionary of dictionaries. It could also be a dictionary of dictionaries, and on and on and on. It could be so nested that, in fact, there is no limitation. So it's just that the deeper it goes, the more difficult it is to understand the hierarchy. Okay, I'm trying to modify a few lines here that. So let me do something here. Yes, let me do this. Here, I want to get Kofo's age. I can see it here, but assuming I want to return just the age. So I could write the same, okay, access Kofo first. Then I know that it's going to return this dictionary. And that dictionary, I could also access the age key there. So I'm going to pass it just as written here. And I'm going to get 28. So that's it. So here I could also get, say, Ola's occupation. And there you go, nurse. Now here, using the dict function to create a dictionary. So what we've done so far is to create dictionary from scratch. In reality, you almost never have to do this. So what is more likely is that you want to create a dictionary from although the first example here is not from an existing collection, or iterable. So, but most likely it's from an existing object that you want to create your dictionary. So here, I'm using a dict function, right? But I'm passing the key as a variable here, and or let me say an argument, then the value as the value of the argument. So I do the same thing here, and I do the same thing here. So let's see it. So there you go. So it works this way. But there's still another way. And we've discussed zip function before this lesson. We've discussed it in most of our previous classes. So if you remember, when you call zip, it creates a list of tuples that matches the corresponding index items from the various iterable that you are zipping together. Here we are zipping students and scores. So provided length of item in student is equal to the length of item in scores. What it's going to do is it's going to take the first zeroth item in student and match it with zeroth item in scores as a tuple. It's going to do the same thing for the first items, second items, the third items until the very last. And when it does that, so I simply call dict on it. And what it's simply going to do is that first items, the zeroth item from both is going to create them into key value pair, where student is going to be the key and score is going to be the value. Exploit it when you have access to this notebook. So let's see it. So Nana 1, Tayo 0, Ubong 8. What I did here is what I did here is not really important for you to understand it now. Those that will be selected for the second round of this training, where we'll be discussing NumPy and pandas. You get the chance to understand what I use this NumPy to do here. I'm simply creating random scores from 0 to 10. So if I were to rerun this, it's going to give me different values. So Nana has 4 here, Taya has 8, Ubon has 8, has 8. Excuse me. So now some dictionary methods. The way list has methods, dictionary too has methods. So the ones we'll be considering here, not like they are not limited to these ones I've listed out here, but we'll just be looking at these four examples, these four methods: keys, values, items, and get. I've mentioned all these in the course of the discussion so far, and we're going to see what they can also be used for here. So here, I call keys, dot keys on my dict. Let's see what it returns. So it simply returns the key values. You can see it dict keys. That's the data type. So it returns the values, the keys. Sorry, I beg your pardon. It returns the keys from my dict. So recall that my dict has Nana, Tayo, and Ubong as the keys. And that is what it simply returns here in that order. So if I want to get the values too, I call dot values on it. It does the same thing. So what if I want to get them as key value pairs? The same way or the same thing that is created when I use this zip function. But remember that zip only returns the generator. You have to call list on it to get the list of tuples. So here, my dict.items simply returns key value pairs. Ubong 8, Tayo 8, Nana 4. So it's similar to what these returns. Let me bring this here. So we can see. So zip student scores. Let me call list on it. Recall I told you zip is just a generator. When you call zip, it creates a generator for you. But you have to convert the generator to list to be able to access it. So let's see it. So there it is. It creates it as key value pairs. So okay, what happened here is, excuse me. Because I see I'm having more key value pairs than I thought I should. Oh, great. So recall that the students list has so many Ubongs, so many instances of Tayo and one instance of Nana. And you can't have two identical keys in a dictionary. So take note of that. You can have two identical keys in a dictionary. So what the dict function simply did here was to collapse the multiple occurrences of a key into one. So it just picks one. And typically the one it picks is the first occurrence of it, first instance of it. So here, Ubong 8 will be picked. Here, Tayo 0 will be picked. And here, Nana 4 will be. No, rather, it picks the last, not the first. I beg your pardon. It picks the last occurrence of it. So it picks Ubong 8, Tayo 8, and Nana. Okay, so we also have get method. Get method does the same thing that this code, that doing this does. The same thing that doing this does is what get method does. So here I want to get the age. So running this, it gives me the age. I could have simply said, I could have simply done this. Sorry, that didn't return a value. Okay. Yeah, my dict no longer has age, but let's see Ubong. It has Ubong in it. It has Ubong in it. So yeah, that's it. So it returns 8. So what if let's go back to what we're actually examining get function, get method. So, but a good advantage of using get as opposed to the other method is that get, even if ubong does not exist in that list, let me change it to ubongo that doesn't exist in our list, in our dictionary, is not going to return an error. Rather, it's going to just return nothing, not going to return anything. So you would prefer to use this instead of the method that is likely to return an error if it doesn't find the key you're trying to get. So let me run it. So you see that it returns nothing here. So, but as soon as it's able to find something, it's going to return it. Okay, so looping through a dictionary. So I have 4 cells that showcases out the various ways you can loop through a dictionary. So here I'm looping through the dictionary flat. When you're looping through a dictionary, it loops through the keys of the dictionary. So let me loop. So it loops through the key items there. So here we have ubong as a key, tayo as a key, and nana as a key. You can see it here, ubong, tayo, and nana. So it brings them out for you and prints each. So what it does is this already has a virtual storage of, let me say, a list of the key values. So which is simply picks each time you run each time it goes for a loop. So, but what if I want to print the values instead of the keys? So knowing that each run, it picks a key value, I can simply call this or do this, pass the key value it prints into a square bracket for it to print out the corresponding value of that. So there you go, it prints the values corresponding to each key. So here, let's see the dot items method. The dot item method, we've seen it from here that it returns the key values as a list of tuple. So each of the tuple contains key value pairs, as you can see here. So when I loop through this, it simply picks each tuple for each loop it runs. Picks each tuple for each loop. So, and it prints them out. So let's see it. So there it is. How about if I want to be fanciful with what I'm doing. So here I'm trying to say, okay, key value. Let me just run it, prints out what. Oh, there's something wrong. Bad operand type for. Let me convert this to string. Should work now. Bad operand type for unary string. Oh, okay. This comma is what is creating the problem. I just removed it, so it should have worked either ways. Okay, there you go. Ubong 8, style 8, nana 4. So recall that I could have used the get method here instead of using the square bracket. Oh, sorry. Where's my point? Dots, yes. So it also works fine. So here there is a small exercise. Investigate what .value method returns and use it in a loop below. So you do it here, you implement that here. So set. So set is simply a collection of items. A collection of items that cannot exist more than once. That's one. And can exist without order. So unlike lists that whichever order you specify gets maintained, Same thing for tuple, which you'll see later. Sets does not have regard for the position of whatever value. It simply collects it and ensures it stores it in memory. There's one important property of set. It can only store one occurrence of a value. So if I wanted to have more than one occurrence of any value, it wouldn't be possible to use a set for that value. So here, let me add another 34 so we can see how it discards multiple occurrences of multiple. Oh, okay. Missing a comma. So you can see that the 34 has been collapsed into one. It's only picking one occurrence of it. The reason for that is set stores each value at a particular location in memory. So 34 is stored at a memory location. If it sees another 34, it simply goes and places it in that same memory location. So it doesn't have more than one instance of it. And you can see that it doesn't maintain the order of creation. The order with which you created the set is not maintained. Take note that when you are performing a performance critical operation, say you are looping, it's a very efficient way of storing value in computer memory. So that is what makes sets very useful. So there's a to do here. Set has so many methods too. You can have sets.intersection, you can have sets.union, then you can even you can subtract sets. So let me have my set minus my set, for instance. It's going to return an empty set for us. So you can see it is an empty set. So because I've subtracted two sets. What if I just wanted to remove, say, 34? So it's going to return the set without 34. So you do this exercise as well. It's going to be a self-assessed exercise. You don't have to turn it in, just do it for your own learning sake. So the last part of this class is tuple. So tuple is a very special data structure in that it is very rigid. And I emphasize on that, it is very rigid. So it's like a list, but what makes it rigid is it is immutable. You're going to come across immutable a lot if you're a programmer, if you write Python codes. What immutable means is it cannot mutate, it cannot change. When something is said to mutate, it can change its form. So, but tuple cannot mutate. Once you create a tuple, it has been created. You cannot add to it, you cannot remove from it, you cannot increase or change a value in it. And you cannot delete any value from it. So it makes it especially good when you want to, especially useful rather, when you want to store any data structure that you're sure is not going to change and you want it efficiently stored. So each of these data structure I've explained, it will appear that maybe one data structure can solve almost all of your problems. Yes, but there are times when you want a more efficient way or a data structure that is more suited to a particular operation than another. So that's why you have to make choice. So understanding the way each of the data structure stores and accesses items is very important. So here you know that the order you have specified gets maintained. You cannot move it around. I'm talking about tuple here now. You can't move it around. You cannot add anything to it. You cannot remove anything from it. So we've created this. So let's print it out. Let's see. So the only thing you can do is you can access the values either by indexing it or by slicing. So here I want to access the second. But you cannot slice. Yes, I'm sorry I mentioned slice. You can't slice it. Say I want to access the first. Oh, I was wrong. You can actually slice it. So you can use index slicing. But what you've done here, you've not changed what exists in this tuple. As far as this tuple is concerned, what is stored is still Solo, 43, and Lily. However, if you want to store this new value, you can simply assign it to new tuple. So you can store it here and access it as this. But this one on its own, you cannot remove anything from it. The top, in my top object, tuple object, you cannot remove anything from it. But you can slice it, you can access any value in it, and you can, I think those are just the things you can do with it. And you can also look through it, the way you can look through lists. So let me give an example of a loop operation. Okay, so I want to separate these so you can see them separately. My top. Sorry. Okay, so here, okay, I'll just make it into a to-do. Okay, so look through and manipulate the items from the top. So you do it here, and at this juncture, we have come to the end of today's session. I'll entertain one or two questions if there are any. Questions? Okay, so in the absence of any question, we shall close today's session. Thank you for tuning in. Have a lovely evening.
Thank you.
Thank you. Thank you, boss.